Hello class, if you weren't here today, I'm going to give you a rundown of what we did. So we started off on page 24, 1 through 6, here's 1 through 3, and number 1 we're asked to basically take these three angles. We've got angle A is an acute angle, we've got angle O for obtuse, and angle R for right. So put those in order from the least to greatest by measure. So of course we're going to start off with angle the angle A, because that's an acute angle, and then if you open it up wider you get a right angle, and then if you open it up even wider you would then have obtuse. So these are the smallest angles, and then you have a right angle, and then you have larger angles with a greater measure. Okay, number 2. The vertex we are asked to find. So if you see an angle and it's named angle BCD, the center letter is always the vertex, and so that's this right there. That point right there is the vertex of the angle. Right there. Alright, number 3. We're basically just going to name all of the angles that we have in this diagram. There are actually 3 angles. There's angle 1, angle 2, and then the entire angle, angle AOC, and I'm going to write those out. So angle 1, you could also call it angle AOB. If you follow the letters A to O to B, that makes the angle. And then angle 2, the red angle here, we could call that angle BOC. Or you can reverse the letters and do angle COB. And then last of all, that large angle all the way from angle angle AOC. It's the entire angle. Okay, next we have here a protractor, and we're asked to find some of these the measures of these angles here and to classify them as acute, right, or obtuse. So let's take a look at the first one. And we get 15 degrees for the first one down here, this angle here, and that's acute. And then we've got the measure of angle TXW, and you can see here this is an obtuse angle. I outlined it in blue, and I'm just following the letters that are in there, TXW, so you can see TXW. And then last of all, this orange angle, angle RXU. And the thing is, it's strange because this one starts off on the left side and then opens up to the right, and in that case we're going to use the outer numbers, because you can see they start the outer numbers start at 0 on this side and go up to 110 degrees, and that's obtuse. Alright, so then what we did after we went over those problems is we took some notes, and here's where your notes start on these 2 problems. So I divided it up into 2 here. Let's look at number 7. Sketching a diagram is important here. So let's make an angle JKM, and we're going to put L inside, is between, and this ray from K to L, and we're asked to find the measure of angle JKM if the measure of angle JKL equals 42 degrees and the measure of angle LKM equals 28 degrees. And what we're going to do is we're going to set these problems up by writing the angle addition postulate. The angle addition postulate says that this part of the angle, this angle here, plus this angle here, equals the whole angle. So that would look like this, okay? And you fill in the blanks. We've got the two angles we've got angle JKL, the measure of angle JKL, plus the measure of angle MKL, those are the 2 smaller angles, equals the total big angle, the measure of angle JKM. And now we're going to look at what we have in this equation, and we're going to try to find values to substitute in for them. So here you see the measure of angle JKL is 42 degrees. Well, that's right here, the measure of angle JKL. So I'm going to write below it 42 degrees. Okay, and then we're going to look to see if there's something we can substitute in for the measure of angle MKL. And here we go. This is the measure of angle MKL, and it is 28 degrees. And then we don't have anything to substitute in for JKM if you look up here, because that's what we're trying to find. There's nothing up there for it. So we're going to just rewrite it as the measure of angle JKM. Okay, so we're going to simplify on the left side these two together, give you 70 degrees. Bring down JKM on the other side, and you can see that we have our answer, because that is what we were trying to find, is the measure of angle JKM, and it's equal to 70 degrees. Okay, let's go on to number 8. Again, we're setting up a diagram, and we are putting in the angles here, that this angle plus this angle equals the total angle. Okay, and we're going to start substituting in whatever we can into here. So we have 56.4 degrees, and that's up here. So this is number 8. Then you see the measure of angle JKL goes in for that. Okay. Now the measure of angle MKL, do we see that up here? You might be at first ready to say that it's 82.5 degrees. It's not. This says the measure of angle JKM, which is this guy down here, not this angle. So it goes in for this one. And we have now the missing angle is the measure of angle MKL. Okay, so we're going to solve for the measure of angle MKL. We want to get rid of this 56.4, so we're going to subtract 56.4 from both sides of the equation. We are left with the measure of angle MKL, that we bring that down, equals, and then 82.5 minus 56.4 is 26.1, and degrees is the unit, and that is our answer. So the key is to set up the angle addition postulate, substitute in the values, and solve for the missing part. Again, angle addition postulate, substitute in the missing value or the known values, and then for the missing one we solve. Okay, and then so we left off here. This is where we got to, and we're still in the middle of this problem, and we'll pick it up tomorrow. And it starts off with just stating that P is in the interior of angle ABC. And just let's do that real quick. If we sketch an angle, we know that B is the vertex, and we put A and C on the direction of the rays. And we know that P is in the interior, so that means we have to put the point somewhere in between the rays. So like it could be right there, P. And then we are going to need the ray BP. Okay, so that's just the basic setup, and then we will go over, we'll finish this problem because there are more questions about this problem. That's not just the whole thing right there. Okay, and that's it.